Okay, sorry about that. The dog made a sound, and so my husband paused it. So we're going to try to finish this problem. Okay, in our steps, we started here. We made it down to moles of N2H4. Then we converted over to moles of H2O2. What's the last step? All we have left to do is go back up to grams of H2O2. So think through, what do you have to do to be able to do that? Okay, hopefully if you haven't written all this down, you need to pause it, okay? So, okay, to change to grams, we've got to have the mass, okay? So find your mass of H2O2. Okay, so we have 2 times the mass of hydrogen plus 2 times the mass of oxygen, 16. Okay, and your answer should be 34.0 ammus, which, what does that mean? That means 1 mole of H2O2 is equal to 34.0 grams of that. Okay, so now I've already erased what we had come up with, but we had come up with that we had 2.45 times 10 to the 5th moles of, I'm sorry, not looking at my problem, of H2O2, sorry about that. Okay, so now I'm going to use my conversion factor. So I know that there are 34.0 grams in 1 mole of H2O2. Okay, so these would cancel out. Okay, and my answer is going to be, again, looking at significant figures, I have 3. I have to stay with 3. I have 8.33 times 10 to the 6th grams of H2O2. Okay, that is an example of one problem. I really want to do one more. Okay, I really want to try to do one more. I know these videos are super long. There are so many examples that you can do of these. Let me tell you some. You can do 8.6, 8.7, 8.8, practice problem 5, 6, or 7, and extra practice problem 1 through 6. There are so many, and they may be worded differently. It may be how much is produced, how much is needed. It doesn't matter as long as they are set up this way. Then this is the way you do it. So let's do one more if it holds out. Okay, let's do. I don't think it even matters which one we do, but let me just find one to do. Let's do extra practice problem number 5. Okay. So everybody turn to page 214 and do this problem. After you have done these with me, I would like you to go through and work as many of those problems that I just listed until you are comfortable, okay? And then if you have trouble, that's when you call me, okay? So number 5 says to make a phosphorus fertilizer, agricultural companies use the following reaction, okay? We have Ca3, P2O8 plus 2H2SO4 plus 4H2O. I don't think I'm on no frame on here. CaH4 P2O8. I should have chosen another one. Plus 2CaH4 SO6. Okay, you have the balance formula already. If 5.000, which means we have 4 significant figures, times 10 to the 3rd grams of Ca3P2O8 are reacted with excess H2SO4 and H2O, how many grams of fertilizer can be made? Don't be confused by the problems because they list all those extra things. You don't need to know all of the extra stuff, okay? Just find the 2 that you're needing to relate for the problem. Okay, so we have Ca3P2O8, which is this one. We have 5.000 times 10 to the 3rd grams. This time we have grams, so we're good. We don't have to change to kilograms. Okay, and it wants to know how many grams of fertilizer. okay? And that is this one over here, okay? And why is it important that we find the right ones? Remember, because eventually we're gonna compare moles to moles, okay, in the problem. So with this, remember our steps. We're going from grams to moles, and then we're relating all the way over here to moles. And we're just going to erase this one because we don't need it. Just remember that's a part of the problem. Okay? And then we're going to relate back up to grams. Okay? These are the steps that we're going through. So let's start right here. What's the very first thing you have to do? Everyone should know the very first thing is we've got to find the mass of this. Okay? So the mass of Ca3P2O8. Okay? Using your periodic table, okay, you should be able to do 3 times Ca, which is 40.1, plus 2 times phosphorus, which is 31.0, plus 8 times oxygen, which is 16, okay, is 310.3. Remember, you always have to go to the tenths place. Okay, so remember, this means 1 mole of this is equal to this many grams. Okay, so we're going to start off with what we have. We have 5.000 times 10 to the third grams of that product. I'm not going to write it out because it takes too much room. Equals 1 mole of it over 310.3 grams. Hopefully you're trying to work this through before I say it. Even pause it and work through it on your own. What would you do? Okay? And so you're going to get 16.11 mole of Ca2O8. Okay? So what are you going to do now? What's the next thing? We've made the step. We've come down to moles. We've got to relate moles to moles. Okay? So we look in our balanced problem. We have 1 mole of this compound is equal to 1 mole of this compound. Okay? So if we write this all out, so we have 16.11 moles of Ca2O8. Now I know you don't have to write this out. You can do this in your head, but it's better to walk through the steps, okay? Is 1 mole of CaH4P2O8 over 1 mole of Ca-P2O8. Okay? And so you're going to end up with the exact same answer, obviously. Okay? You're going to end up with 16.11 moles of CaH4P2O8. Okay. So now, we've made it here. We've made it here. All we got to do is go back up to grams. And just like I told you, I got to erase. Okay? What's the next thing you have to do? To get it back up to grams, how can we relate moles to grams? Purely through the atomic weight. Okay, so let's do that. What is the mass of CaH4P2O8? Okay, so we have 1 times Ca, which is 40.1, plus 4 times hydrogen, 1.01, plus 2 times phosphorus, which is 31.0, plus 8 times oxygen, which is 16.0. Okay, and your answer is 234.1 AMUs, which is 1 mole is equal to 234.1 grams. Okay, that's our conversion factor. Okay, so the last step we have to do is take the thing I had to erase a minute ago. We have 16.11 moles of CaH4P2O8 over 1 times 1 mole is equal to 234.1 grams. And your answer should be, again, I haven't been saying anything about significant figures, but you should have 4 here, and so you should have 3,771 grams of CaH4P2O8. And remember, this is the stuff that matters because this is actually usable. You can't use moles when you're actually doing an experiment. But by doing what you're doing, you could actually do an experiment. If you knew you had this much of this with this equation, you could convert it and know how many grams of this you needed. Okay, so again, I'm going to name off the problems you probably need to work through until you feel comfortable. On your own, 8.6, 8.7, 8.8, practice problems 5, 6, and 7, and extra practice problems 1 through 6. I know these are a little difficult, but I think if you work through them, you're going to all get them. Call me or whatever with any problems.